30 minutes, we'll be done. Great. Our next presenter is Deanna Whitehead.
Okay, hopefully I've got this mic in a good position. It's kind of sneaking its way down, so I apologize about that. So I'm Deanna Whitehead. I'm from Marshall Space Flight Center. Until about 2 weeks ago, I was the SLS Flight Software Design Team Lead. I've just moved over to support Gateway, so I'm excited about that too. And I just want to say I hope everyone is having as much fun in here as they are out there. They're having a lot of fun. So anyway, I'm going to talk to you today about some of the steps that we've taken to ensure that our flight software is highly reliable. Okay, so just an outline. I'll talk very briefly about the SLS vehicle because I'm sure you're all fairly familiar with that at this point. Just our flight software overview, our Modified-Scrum process that we use, how we very tightly control our changes, and then some of the steps that we take for every software change that we have. And then I have some inspirational propaganda at the end if we have time. Hopefully it'll work. Where do I click it? Where do I point it? Okay. Okay, so like I said, you've already heard about SLS, our powerful rocket that's targeted for deep space exploration. So the point I want to make here really is that this is a national capability. You know, we have industry partners and centers all across the country that's contributing to this. So we're proud of it as a nation. We're contributing to our nation's economy. It's very important to us at Marshall Space Flight Center and in our software design branch to make sure that our mission is successful. One thing I will mention, like I said, we're spread out everywhere, and we've been given the opportunity to develop this software in-house, which is a big deal because most of the other pieces and parts are being developed by a prime contractor, but all of this work for the flight software is being developed here at Marshall Space Flight Center. Okay, so we've already talked a little bit about our NASA procedural requirement, 7150.2. We're on Rev B for flight software. You know, that helps us determine what classification our software is. So in this case, it's human-rated flight software, so pretty easy determination, and that's going to be Class A, safety critical. You know, our software is controlling some safety critical functions. We could damage the vehicle, you know, we could cause a loss of mission, so we have to do a lot of rigorous activities to ensure that that doesn't happen. We're using the ARINC 653 standard. We're developing in VxWorks 653 that offers a partitioned operating system, which gives you protection in space and time. So your memory is protected, your time is protected. We're also developing in C++, which, you know, when we made the decision at least was a bit of a change to move from C to C++. We're still under C++ 2003. I think someone mentioned earlier, you know, some of these standards are centered around those older versions, and ours certainly is. Our coding standard is based on the JSF++ standard. And we have about 50,000 lines of code, so it's not huge. We have some auto-generated data tables and headers and things like that that we're not counting in that count, but as far as our handwritten code, it's about 50,000. I also meant to mention, obviously, we're CMMI level 3. That's required for any Class A safety critical software. So I'm actually going to skip ahead one. I'll come back to this. So even though we haven't launched yet, for the flight software, we're in a maintenance mode. That means we've released what we think is our flight candidate of our code. So we've hit that milestone. And so because of that, all of our changes are very tightly controlled. So we have what we call the avionics and software control board. Now, of course, there are boards up above that, and I'm not going to get into all of that, but our closest one is this ASCB. And what will happen is that a problem request or a problem report can be submitted through this board. They could come from other disciplines, so maybe GNC or maybe the engines or any number of places can come in through there. So we have a board of people who'll decide if that is a real problem, if it needs to be addressed right now, what ramifications or if there are mitigations that we could do to control that. And if they agree that we need to make a change as a result of it, then it flows down to our team. So the SLS Flat Software team will get a change request. And so then that's analyzed by our requirements team, our design team, test team, everybody to determine what kind of changes we need to make. Okay, so if that's all approved, then it flows down into one or many design team CRs. So that outlines exactly what we're going to change in the code. Okay, so we have a change management tool called Serena or Solutions Business Manager, and that helps us track any PR, CR that we have that enters our system. Once all of the approvals are given at those various levels and the design level CRs are moved to an implementation state, which is determined by the lead, the developers are ready to begin work. So we're using Subversion right now for our code repository. And so each time that we get an approved CR, I, as the design team lead, would create a branch for the developers to go off and do their work. Pretty common paradigm there. We have, unfortunately, we don't have a completely integrated system for our change management and our code management, but we have some specialized code that we've written that allows us to track each commit. So anytime a developer checks in, a note is added. Oh, louder. Okay, thank you. A note's added to the CR. Is that better? I'm just going to hold it. Okay. To the CR so that we can go back and check, okay, exactly what changed. Okay, and so that's been very, very helpful as we're trying to stay on top of exactly what's changed. Okay, so now I'm going to go back to my previous chart here. So we use a Modified-Scrum Lifecycle, and part of the reason I wanted to go through that whole board approval and everything before I talked about this is so that you can see why certain things are happening outside of our normal sprint cycles. So all of that, PR coming in and deciding if this is a worthy change or not is happening outside of our sprint cycles. So once that is decided, then we work with our sister organizations for mission and fault management, vehicle management to determine if there are algorithm changes, requirement changes, or whatever. Once all of that's decided, then we follow a pretty basic sprint cycle. The only thing that's a little different, we do mostly a 6-week sprint cycle because we're including a week to integrate. So we've found over the years that it takes about a week for us to integrate all those CRs, make sure that our system response is still what it's supposed to be. And then we have our configuration management team that creates our releases. So they get a week too. And what happens once we have that release is it goes to our formal testing facilities, which I think you've already talked about, the SIL. Some people got to tour yesterday. Okay. So like I mentioned before, we have a coding standard that's based on the Joint Strike Fighter. We have an automated tool that checks that. We're running it every night on our integration branch. We're using a tool called PRQA to do that. We also leverage our IV&V folks. They have some other tools, so every time we have a dev tag come out, we get it to them and they run it through their tools as well. So for code coverage, we have the pretty common branch and statement coverage, but we've also committed to 100% MCDC coverage. So that's the multi-condition decision coverage. So it's a little above and beyond, we think. Again, that's executed every night. For each of these, we get an email every morning telling us if there's a new failure, how many tests were executed, and all that. Also, we have functional testing. So we've written our own test harness in-house to allow us to do module level testing. So that's kind of just function level testing. And we have over 1 million of those tests that run every night. So gives us a warm fuzzy when we see those all pass. I didn't put on here, but I'll also mention we have a trace report that runs every night. So we make sure that every requirement is traced to our design and to the code and to the test and back. So we check that every night too. Okay, so once a developer has gone through all of those steps, the CR will go into a quality check, and that provides a peer review for each change. It makes sure that the code was changed as we expected and no additional changes were made, so we can't sneak anything in there. It checks that the unit testing results are 100% like we expect, the functional test results as well as the static analysis. So we do all of that before anything is promoted to our integration branch. Also, we get ready for doing the integration. So the developer will recommend what kind of testing they think should be done for each CR. So some options are fly out. So we have another tool that allows us to queue up a scenario and fly the rocket using Artemis and Maestro, which I believe you heard about this morning, and then analyze the results pretty quickly. We also do a lot of batch testing because we have an asynchronous system. So we really need to run things multiple times just to make sure that we understand what the behavior is going to be. Okay, so once all of that's been done, we integrate the CR. We make sure that all of those overnight tests will run on the integration branch with everything else, because sometimes we see new errors when everything is integrated together. We run any simulation or extended unit tests that need to be run and notify the developer of any issues that we see. And we just continue that until we're all happy. Okay, so just a summary, lots and lots of automated testing. We're continuing to add more every day. We're continuing to do off-nominal scenario testing. We have some developers that are really good at coming up with bad day scenarios that we're testing. Let's see. So one thing that we've talked about previously, but with the system integration testing, we're seeing new questions and issues come up as a result of that. So we're glad to have additional people taking a look at everything from a different perspective. Okay. Is there sound? No. Oh, there's no sound. Okay. Well, maybe we'll just skip this. This is a nice video. I think it's called We Go, so it's out on YouTube. You can go out and see it for yourself when you have a chance. So if you have any questions after this, you can feel free to contact me. There's my contact. There's a little article about what we do here at Marshall. So that's it.
We have time for questions.
Thank you very much for the presentation. I have actually a couple of questions, if you don't mind me asking. So, given your experiences on SLS, and you said you were going to Gateway, what lessons have you learned that you're taking to Gateway to do its development effort?
So there are a couple of things. I mentioned that our coding standard is modified JSF, so it's custom, which means that we've had a multitude of problems getting our static analyzer 100%. So I think one lesson learned is to go with the standard if at all possible. Another thing is that, we didn't do all the automation from the beginning, because that takes time. You want to develop the code instead of getting maybe that whole testing framework completed. So I think that's a lesson learned as well, is just to do as much of that up front as possible.
So it's actually my second question was, do you do test-driven development since you have an agile workflow for? Okay, and then the other is, I'll speak for Jake. Can you guys consult on unit testing for Core Flight?
Oh, can we consult? Yeah, I think that is something that we're gonna work on. Yeah, because we're using Core Flight systems, so we'll be doing lots of unit testing and everything too. Yeah.
Other questions? We'll go back here.
Yeah, I'm just curious about the the heritage of the flight software for SLS. How much of it was really new versus legacy from a previous project? And also, do you know or project what that percentage will be for Gateway? Will that be 100% new?
So there was some heritage from Ares, which was Constellation that was canceled. But other than that, it was completely new. We used some, we do have a couple of people who worked Shuttle, obviously, and even Apollo. And so we do leverage their knowledge to help us with things that they learned over the years. But it's a completely new, new architecture, so completely new code.
Yeah, I'm not sure I can completely understand why would you need to go to a 6-week sprint when you have like a million set of unit tests plus integration tests. Why do you need to have 6 weeks? What is the problem in the integration then? Hardware?
Sometimes, because we have 2 lines in our lab, so there is some hardware timing limitations for us to run all of our integration tests and everything. A lot of it is just coordination. I'll be honest, just coordinating, outside of our organization, just to make sure that we're doing exactly what our, I would call them our customers want us to do. Because like I say, at this point, we're making changes because there was an issue found. Lots of times it's a hardware workaround and things like that, and that slows us down. But you're right, and it does help. But I tell you, every time we do a sprint, we usually face some different issues. So when we get everything in our integration branch, there's always something. And so we often deliver early, but we allow ourselves that time.
Okay. And do you also have integrated hardware for the nightly builds? You go continuous integration down to the hardware level?
So we have engineering units that we're running on.
Okay.
Is that what you mean? So,
Yeah,
so we are running on that hardware, but we're not running like in the SIL every night, obviously. So not with that hardware. We're running with Artemis and Maestro, which is our simulation environment. But we are running with that environment.
Okay, thank you.
Mm-hmm.
So there are a lot of really good and useful process steps here. I'm wondering if you could say which one did you find the most useful, and which one did you find the least useful that you might reconsider in the future?
Interesting. Let's see. I got to look back at what all I told you. I really think just having all those nightly runs, that's probably the most useful, just to ensure that we haven't introduced any bugs. Also, like I say, and I know it does extend our sprint duration, but allowing that time for integration, I think that was a hard lesson learned. But let's see, the least, waiting for all those inputs to come in, that's the least fun, right? We have to do it, though. Is that it? Oh, okay.
So when you were talking about static analysis tools, do you only use one, like the PRQA Helix, or do you use multiple?
We only use one ourselves, but like I said, we have our IVMV facility in Virginia, and they have multiple. Like I know they have Clockwork, and I don't remember. I think they have a few, and so they always run those for us for every dev tag that we create. So any possible release version, we're getting all that feedback. So now it's not specific to our coding standard, but if they find something that's an issue, we want to fix it anyway, even if it's not violating our standard. So we always go through that. And over the years, it's gotten less and less the things that they find, thankfully.
Is IVNV open to all NASA centers to have them analyze code?
I think they are, but obviously they're restricted on time. So I think that goes back to your software classification. I don't think they're going to step in on anything that's below a B, maybe a C classification. So I think it's restricted in that way.
Thank you.
Mm-hmm.
Yeah, just to answer kind of that question, and I don't know, there's a couple other IVNV folks here, but it is based, it's independent, so it's not tied to the projects, and it's based on, of course, limited funding and whatever, so they set goals for what projects are going to do, so that's kind of how it works, and end up with like I said, during my presentation, the Class A software, especially mission critical or manned space flight. That's why SLS, Orion, Kennedy are on that list. And then usually other very high profile, high dollar missions like James Webb.
That's true. Now, we've had something recently that was classified as a B, and it wasn't as high profile. So, we do try to make sure that more than anything, it's based on the function. If there's anything, if you're controlling a heater, it doesn't really matter what you're doing. But there is also a monetary boundary. If you go above this, it's going to be a higher classification. If you fall below, you're lower classification. So, it also goes into the altitude. So what kind of airspace you're actually going to be in, and things like that too.
Questions? No. Thank you, Deanna. Our next speaker is Sean Phillips.